looking at is data redundancy. So we're going to be looking at data redundancy. Okay, that's the next concept, data redundancy. So data redundancy measure, I mean, storing multiple copies of the same data in different places so that if one copy is lost or damaged, another copy can be used. So we talk about data redundancy. Remember, we talk about we're still in the vein of resilience and redundancy and redundance. Meaning, when we said resilience, that we have the system is at such that if there is any disaster or any disruption, the system can continue to run. So when we talk about when we said data redundancy, we're saying redundancy means storing multiple copies of the same data in different places so that if one copy is lost or damaged, another copy can be used. And there are so many things that can happen to data on a system, and that will create some form of disruption. And it does make sense that if you're running a business, if you're having a data, if you're in um, cybersecurity, that you make the provision just in case there is a problem, just in case there's a data breach and ransomware. They lock your computer down, encrypt your system so you cannot get onto it, or inject virus, or do some form of malicious attempt on your system, that you are able to recover any data. It's very important, right? So let's say Google Drive automatically saves your documents in the cloud. Even if your computer crashes, you can still access your file from another device. And that's the beauty of Google Drive and the cloud. And that as because once people would struggle, literally struggle to, how am I going to retrieve the data? There's no, but in the olden days, what they used to use, they have USB, or they use a CD to put the information on. Then we went from the USB age. I'm sure that there are still USBs that people are using. And then now you have the cloud. The cloud can back up all your data now, and you can sign in from multiple locations no matter where you are. You can access Google Drive. All the information are backed up now, and I think this was a brilliant idea. And I'm sure even though there is a cloud space, that people probably still using USB, or thumb drive, to store their data on, or maybe some people still using paper and pen, right? Some people probably still using paper and pen for, to have their data available should the worst happen, right? So the worst of the worst should happen. I'm sure people still using those kind of means, okay? So that is something very important. People are still using those, which is very interesting, extremely interesting, right? That people are using, still using paper and pen, okay? So we look at this example of Google Drive, which is a prime example, that we can use. So let's move on. So redundancy. When we say data redundancy involve creating multiple copies of data across different locations or systems, right? And this protect against data loss due to hardware failure or natural disaster or a cyber attack. That's the main reason we are doing all of this data redundancy, because there can be a hurricane, there can be an earthquake, there can be other disaster, natural and man-made disaster that happen, and we want to know that if any of these things happen, then there are backups. There are backup internet. Remember, we talk about failover, and we talk about the UPS, the uninterrupted power supply, right? So we want to know that if there is any issue, we are not the company, or your company that you're working with is not the one that is going to go down. And we have data can be replicated, right? We can synchronize the data. We ensure real-time updates across all copies. That is very important. And we make sure that um, constantly there are copies, there are updates that are being made. For let's look when we look at the cloud storage offers an effective solution for data redundancy, such as data is stored across multiple data center, minimizing the risk of a single point failure. And that's what we're trying. We don't want a single point failure causing the entire organization or the entire network or server to just in total darkness. We have to have some kind of um, data storage. So let's look at some scenarios. So that is what we'll call data redundancy, right? Having multiple copies, having several copies in place just in case the system goes down. Let's look at this scenario. A customer database in retail store. A retail store maintains a customer database that include the following files: customer ID, name, address, email, phone number, purchase history. However, due to a poor database design, each time a customer makes a new purchase, their personal details are stored again, leading to multiple records of the same customer issues. Customer Multiple records of the same customer. The issue is inconsistency, right? If a customer update their phone number, some records may still have the old number. Waste storage, repeat storage of the same customer information, um, customers unnecessary consuming unnecessary space. The problem, data management, generating report becomes difficult due to duplicate data. Solution: use a normalized database where customer information is stored in one table and purchase are linked through the customer ID instead of duplicating the personal detail, because this becomes a challenge. Because if we're trying to do redundancy and all of that, and it's a means of copying customer data so it can be stored in other locations, so if there's a problem, we are able to retrieve it. And now what you realize is just storing the same information over and over. We don't want that. We want new data to be storing across platforms. Scenario 2: employee records in a HR system. A company keeps multiple Excel spreadsheets, right? To store employees' detail. One sheet contains payroll information, another store performance review, and yet another keep contact details. Since the same employee data is manually entered in multiple places, changes like name change due to marriage must be made in all sheets separately. The issue: data inconsistency. Some spreadsheet might not be updated, causing confusion. Manual error. High risk of mistakes when manually copying data. This is a problem. Who in this time and age, I don't know if people really want to sit down doing copying manually, but you can have a problem. Time consuming updates. HR must update multiple record instead of just one. Solution: implement a central HR database where all departments access the same employee profile, reducing redundancy and ensuring accuracy. Right? So we said data redundancy, we will creating multiple copies of data across different location, right? So you see that it's data redundancy. Storing, it means storing multiple copies of the same data in different places, so that if one copy is lost, another. So that's the aim. But what we don't want to happen is the manual doing of entrance of the data. So when we do that, sometimes what happens is that some areas don't get to be updated and some areas. So we want to make sure that we implement a centralized HR database system. So once it is changed in one location, it is changed in all the locations. So that's what we are aiming at. Do you get that? So the solution to the problem is, since it's a all these information is very important, and we want to make sure that there is no error in storing the data, we want to make sure we make it centralized. Another scenario is an e-commerce product catalog. An e-commerce website has thousands of products listed under different categories. Instead of storing product details in a single location and linking categories, the developer create a separate copies of the same product for different sections. Example, electronics, bestsellers, discount item. The issue that we're going to look at, difficulty in updates. A price change require modified multiple records. Data inconsistency is going to be a problem right here. Some variation of the product may show outdated description, unnecessary storage use, multiple entrance of the same product takes up excessive data space. One of the solution that we can use in this is use relational database design, where products are stored in a single table and categorize, reference them in via product ID. All about storage, being able to store. Scenario 4, medical record in a hospital. A hospital maintains separate database for different departments, right? They have radiology, cardiology, and billing and all of that. Emergency, right? Each department creates its own patient record, resulting in duplicate entry for the same person. The issue, medical inconsistency. If a patient al- allergies or medical history are updated in one department but not in others, it could lead to serious error, right? Increased storage costs. Multiple database require more storage and maintenance. Data retrieval issue. Doctor may struggle to find the patient full history. Solution, implement an electronic health record that allows centralized access to patient information across all departments, right? So we have to ensure that they are centralized across all departments. We just don't want one department to have the problem of just entering the information and then one area is fixed and then another area is another problem. Scenario 5 is cloud storage for business. A company uses a Google Drive and Dropbox to store its project files. Employees frequently update the same document to multiple folders and share the same repeatedly through email. The issue is version control problem. Different employees work on different copies, leading to confusion. Waste cloud storage. Redundant copy takes up unnecessary space. Difficulty in collaboration. Finding the latest documents version becomes a challenge. Solution that could be implemented is use a single cloud-based document management system with variation control and access settings to prevent redundant file storage. So that's how we would work that one. So let's look at some multiple choices that has to do with redundance. What we said, what is redundance? Redundance a, is it a backup system for data recovery? Is it B, a duplication of data in database or storage system? C, a techniques used to increase database security. D, a method of compressing data. And we said redundancy is the duplication of data in database or storage system. But remember, these data's duplication have to make sense. It cannot be duplicating the same information, like, you duplicating the same information that doesn't make sense. The duplication of the data must make some level of sense. So when you're duplicating it, it is storing. So any you as you duplicate it, you are making it store in different area, but it should not be duplicating of your name 10 times, right? Your name is there again. Whatever information is added or whatever you did, that will the data needs to um to to change and change right across the platform. That is what needs to be done, not constantly duplicating your first name, constantly duplicating your last name, which don't make any sense because it's already in the system. So it's taking a whole copy of this lesson, right? So let's say from the start of the class, we would have duplicate everything. And so today we're looking at redundancy and resilience. So that would be updated right across the board, right? So it wouldn't be a duplication of the CIA triad, just duplicating the CIA triad in want of a better example, right? But see, we had the CIA triad, we had other areas that we look at too. And let's say those were duplicated because across different platform, and today we come with this lesson, we're going to add this and have it, you know, centralized, so every file is uploaded with this information. You see what I'm saying? Which of the following is a major drawback of data redundancy? What will be a drawback to this? Right? Is it A, improve the system performance, B, increase storage cost and data inconsistency, C, faster data retrieval, D, better network security? And one of the drawback that we will find in redundancy is increase in storage costs and data inconsistency. And why so? Because sometimes one area is updated and another area, especially when there's not a centralized system, especially when people are trying to do this thing manually. And so you have this all increase of storage costs because the same information is taking up the same space. There is not like in a way where the information that is within the storage area, that it is data that is constantly being added to, right across the board. Sometimes the duplication, like I said, is the same lesson. You keep duplicating the same thing, right? And it keeps increasing the storage costs and data inconsistency. And nobody wants that. If it's going to increase the storage costs, it must be for a good purpose. That's what I would say. Because data is constantly changing, there's constantly addition to data, right? So we want to make sure that whatever it's copying what is relevant. And of course, as your business increases and as data increases and as there are more data being added, it's going to increase the storage cost. But we don't want that cost to be because of unnecessary data. That's why we talk about how long you keep data for. There's a stage in the data cycle where you have to destroy the data, where you just take it for the purpose of which you have. But there are organizations like Facebook and all those kind of places, you got to hold to the data. Hospital, all of these places, there are data that you must keep and you must store them and you must have multiple copies of these data, right? And that is absolutely important. Which of the following best describe an example of data redundancy? An example Is it A, using a cloud-based backup service? B, um, customer details being stored multiple times in different table of a database? C, encrypting sensitive customer information. D, a company updating employees' record in a single centralized database. And we'll go with B for the answer. So the data redundancy example would be a customer details being stored in multiple times in different table of a database. So it's stored multiple times, different. Remember, this is multi. So it's not a single place, it's multiple. So it's storing over there, it's storing over here, and it's storing elsewhere. For the purpose of, should there be a cyber attack, should there be a disaster, you are storing them in multiple places. Do you understand that? Extremely important that we understand why we do redundancy. For how can data redundancy be reduced in a database? How can data redundancy be reduced in a database? By using the data normalization, by creating duplicate records internationally, by increasing the number of spreadsheets, by deleting all old data. So we can reduce it by using data normalization, right? So that's a way we can reduce it. Which of the following is not a negative effects of data redundancy? Which of the following is not a negative effect of data redundancy? Data inconsistency, increased storage cost, fast data retrieval, more time consuming updates. So which the one that is not a negative is fast data retrieval, because remember, in redundancy you are able to retrieve the data, right? High availability, you are able to retrieve the data when you need it, and there shouldn't be a problem. But the rest are negative, if negative effects of redundancy, except that one. Which type of database design help eliminate data redundancy? Flat file database, relational database with normalization, decentralized spreadsheet management, manual paper record. And I put these multiple choice in so you could think, right? So which of these can help to reduce redundancy? And it will be relational data with normalization, okay? A hospital maintains separate database for building and medical record, leading to duplicate patient entries. What problem does this cause? So the hospital maintains separate database for building and medical records. So they don't have a centralized system, they don't have a one database system that controls everything. This leads to duplicate patient entry, because you have to make a whole entry for the patient building, and then make a whole entry, so you have in the building, you have the patient name, the patient information, what they're paying for in the medical, the name, their address is the same thing in the building, their phone number. So these are double entrance, right? And these lead to duplicate because they have two of the same patients. So is it A, better security and organization? B, increased risk of inconsistent patient data? C, faster medical record retrieval? D, improve patient care? And we will put B because it increased the risk of inconsistent patient data, because it's duplicate in different places. So the solution is to make one central system where the building and the records is on the same system. And let's say you probably don't want, like we said before, that the billing people to see the medical record, but you could make it so that when the medical bill is paid, the information is, it's centralized. They can see it's updated in other area. In a company's HR system, employee details are stored in multiple spreadsheets. What is a better solution for this? If the employee records are spread in multiple spreadsheets, what is a better solution to avoid redundancy? What will be a better solution? Is it A, manually update all spreadsheet regularly? B, store all employee data in a single central database? C, delete all the record frequently? D, create multiple copies for backup purpose. So in a company, the employee details are stored in multiple spreadsheet, right? Multiple. So the answer will be B, store all employee data in a single centralized database system. So if in a centralized system where it can be accessed, it can be updated. Which of the following best describe normalization in database? Is it the process of intentionally duplicating data for security? B, a method of structuring data to reduce redundancy and improve efficiency? C, the techniques of encrypting data? D, a way to increase database size. So, which of the following best describe normalization in database? So, we would say that it's a method of structuring data to reduce redundancy and improve efficiency. We don't want the same name to be seen and double entries and billing do their own stuff and medical doing their own stuff. We want it to be structured to reduce error. Okay. An online store lists the same product multiple times under different categories. Bestsellers, electronic, new arrival. What issue does this create? They list the same product multiple times under different categories. Is it easier customer navigation, data redundancy, and potentially inconsistency? C, data product visibility, improve performance of the database. So this leads to data redundancy and potential inconsistency. That's what it creates. Um, Let me see if I had. Okay, yeah. So I'm going to go into RAID. Okay. So configuring, we're going to look at RAID. What is RAID? Right? RAID is a system that connects multiple hard drives to improve performance and protect data. Right? So it's a system that connects multiple hard drives to improve the performance and protect data. Some RAID level focuses on speed, while other focusing on keeping backups in case of failure. So that's what the RAID does. So remember, it's a system that connects multiple hard drives to improve performance and protect the data. And some RAID levels focuses on speeds, while others focusing on keeping backups in case of failure. Let's look at an example. A business may use RAID 1, which mirrors data across the drives, right? If one fails, the second drive has all the data. So this is what we mean when we said we using RAIDs. Okay, remember what RAID is. Keep that in your mind. It's it connected multiple hard drive to improve performance and protect the data. and you have different RAIDs. So yeah, let's look at this scenario. RAID 0 for a high performance gaming PC solution. John is a professional gamer and a video editor who needs a maximum speed when loading games and rendering videos. His system has one TB NVMe SSDs, right? And he wants the best possible read write speed. The solution is set up a RAID 0 stripping, right, which distribute data across both the SSDs without redundancy. And this will increase the performance as both drives work together, making gaming and video editing much faster. The risk though, since RAID 0 has no fault tolerance, if one drive fail, all the data is lost. And John should maintain a regular backup to prevent data loss, because in this RAID, it is 0 and it don't have any tolerance. So when you are using any form of RAID, it must have some level of tolerance, right? Fault tolerance. If it doesn't, you have to constantly be backing up your data, and even so, data needs to be backed up. So let's look at another one. RAID 1, so you have 0 and you have 1, right? So remember what we said that RAID is? It has all that to do with what? Let's go back so you don't lose the essence. So we said a RAID is it connect multiple drive to improve performance and protect the data, but I think I'd missed this. So in this RAID, we said in the 0, the configuration distribute data across multiple server, and it's increased performance but offer no data redundancy. So we wouldn't want to use this. And we said that RAID 5, it combines stripping and prioritizing information. It paired information or send information across the drive, offering both performance and redundancy. And RAID 1, it creates an exact copy of the data. It mirrors the copy, but we're going to see this a little further. So let's look at RAID 1, right? So it said RAID 1 for small business service. A small accounting firm need a secure backup solution for its financial records. Losing client data Losing client data due to drive failure is unacceptable. The firm has a 2 TB HDDs, right? So the solution to that problem is the IT admin configured a RAID 1. So it's mirroring, it's doing the exact copying, right? Which is what we want, where the second drive is an exact copy of the first drive. And that's what we want. If one drive fails, the system continue running on the remaining disk without any data loss. And the benefit is high reliability, ensure business continuity. Drawback, storage capacity is cut in half as one disk is always a mirror. But even better yet, the system is able to function at a proper rate. So let's look at another scenario. RAID 5 for a corporate database server. A medium-sized company runs a data server that requires both performance and fault tolerance. They have 4 TB HDDs and want an efficient RAID setup, right? The IT team sets up a RAID 5 stripping, right, which use one drive's worth of space for parity while allowing recovery from a single drive failure. If one disk fails, the data can be reconstructed using the parity information benefits because it's copy. Good balance between performance and storage and redundancy, right? More usable storage than RAID 1. 3 out of 4 disks are used for data, right? The risk, if two drives fail simultaneously, all the data is lost. That is just the risk with this one. RAID 10 for a mission critical financial system. A banks need a high performance, high redundancy storage space for its real time transaction processing server. Losing financial data is not an option. Solution: the bank configure a RAID 10, right, using A2 TB SSDs, and this setup mirrors pair of drives, right? And then it stripped them, right? Combining speed and fault tolerance. So this provide high performance, excellent redundancy, mirroring, can survive multiple drive failures as long as one drive per mirror, right, remains functional. The drawback is it is expensive. It required double the storage to maintain full mirroring, but I would prefer this one because even though you don't have any data loss here should they fail, right? It can survive multiple failures. So that is what we when we talk about. Okay. So we're going to go into the next part of the lesson. Um I didn't, let me go back here so we could pick up from here. So we deal with data loss. Now we're going to go into, we did RAID. Yeah. Okay, so I was wondering, so we didn't finish. So we have the multiple choice aspect of the RAID to do. So we have the multiple choice. So we're going to go into multiple choice now before we move into. I wanted to see what the multiple choices are like. So let's look at some multiple choice. What is the primary purpose of a RAID? Is it A, to increase computer speed, B, to enhance storage performance and reduce and redundancy, or both, C, to replace cloud storage, D, to encrypt all storage data? And the answer is to enhance storage performance and redundancy, or both, right? Which RAID level provides the highest performance but no fault tolerance? And we said, is it A, RAID 0, B, RAID 1, C, RAID 5, D, RAID 6, and we would use RAID 0. We said RAID 0 has a high level performance, but it does not have any fault tolerance. A company need a RAID configuration that can survive up to 2 drive failures. Which RAID should they use? Is it RAID 1, RAID 2, RAID 5, RAID 6, or RAID 0? They can use RAID 6 for it because it is able to survive up to 2 drive failures, right? The RAID 1 is also known as what? Stripping, mirroring, parroting, coaching. And we said RAID 1 is also known as mirroring. It makes exact copies. What is the main disadvantage of RAID 0? Is it A, high redundancy, C, reduced storage space, that's B, sorry, C, no fault tolerance, D, slow performance? And the answer will be no fault tolerance. So one of what the main disadvantage of RAID 0 is no fault tolerance. It don't have any fault tolerance. Remember that. A business needs both speed and redundancy. Which RAID setup should they choose? They need speed and they need redundancy. Which RAID setup should they choose? Which one do you think is the best one for them to choose? They need both speed and they need they need speed. What did we say they need? I jump off of that. Okay. We said they need both speed and redundancy, right? So which should they use? They're going to use, is it A, RAID 0, B, RAID 1, C, RAID 10, or D, RAID 5? So if they need both speed and redundancy, they should use RAID 10. How many drives are required at a minimum to set up a RAID? How many drives require at minimum to set up a RAID? Is it 2, B3, C4, D5, and we need a minimum of 3, right, to set up a RAID. In a RAID 5, how many drives can fail before data is lost? Is it A0, B1, C2, D all drives? So in a RAID 5, it needs one drive to fail before data is lost. So it needs one file to fail before the data is lost. A gaming PC user wants to maximize speed but doesn't care about redundancy, right? So a gaming PC user, they want to maximize speed but they don't care about redundancy. Which RAID should they use? They could always go with, is it RAID 0? Is it RAID 5? Is it RAID 6? Which one? RAID 1? So it will be 0 because they just want to maximize speed but they don't care about redundancy. A hospital wants to ensure patient records are always backed up in case of drive failure. Which RAID is best? Is it RAID 0? Is it B RAID 1? Is it C RAID 5? Is it D RAID 6? And we will put RAID 1 because they want to ensure patient records are always backed up in case of a drive failure. Okay? What is the key difference between RAID 5 and RAID 6? What is the difference between RAID 5 and 6? RAID 5 is use single parity while RAID 6 use dual parity. RAID 6 use faster drive than RAID 5. RAID 5 require more drive than RAID 6. RAID 6 does not provide redundancy, and the answer is RAID 5 uses single parity while RAID 6 uses dual. What is the major disadvantage of RAID 10? Is it A, it is very slow, B, it doesn't offer redundancy, C, it requires twice the storage capacity, D, it only works with SSD. And we will go for C, it requires twice storage capacity. Next question, what is the minimum number of drive required for a RAID 10? Is it 2, 3, 4, or 5? And the answer would be C, 4. If you want to create a balance between redundancy and storage efficiency, which RAID should you use? If you want to create a balance between redundancy and storage efficiency, which RAID should you choose? Is it RAID 0, RAID 1, RAID 5, RAID 6, and we'll go for RAID 5. Number 15, a cloud storage provider needs the highest level of fault tolerance. Which RAID should they use? Is it RAID 1, RAID 5, RAID 6, or RAID 10? And we will say go to RAID 10 because they need high level of fault tolerance, right? Which of the following RAID level requires the most storage overhead? Which of the following require the most storage overhead? Is it RAID 0, RAID 1, RAID 5, D RAID 6, and we said RAID 1. As cybersecurity firms need to store logs securely while ensuring data integrity, what RAID should they use? Is it RAID 0, A, B RAID 1, C RAID 5, D RAID 10? And we said they should use RAID 10, right? Because they need to secure the data, right? As security firms, they need to secure the data. Which RAID level provides the most efficient storage space utilization? Which RAID level provide the most secure storage space? Which of them provide the most secure storage space? Is it A, RAID 0, B, RAID 1, C, RAID 5, D, RAID 6? And the answer will be RAID 5. Which of the following RAID configuration does not provide redundancy? RAID 0 do not provide no form of redundancy. Okay? So you got to remember that. So we're going to jump into um, capacity planning, right? So we talk about capacity planning. So let's look at the definition. Capacity is another concept that we're going to look at. Capacity planning involves making sure a system has enough resource like storage, processing power, network speed to handle future growth and unexpected spike in demand, right? So we talk about capacity planning. We're planning so that when we are building the system, when we are building the 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 application, whatever we're going to do, we are building it so that it makes sure the system has enough resource like processing power, network speed to handle future growth. So we have to make it so that it can handle. We have to build Facebook so Facebook can handle tens of thousands of people, millions of people on Facebook. Some people have 5,000, 5 million followers. We have to build it so it can handle the traffic, handle the store. So let's look at an example. An online store preparing for Black Friday needs to plan for more website traffic. If too many people visit at once and the server isn't ready, the website could crash. So we have to make sure that we are building it. So, and capacity planning, creating capacity planning involve forecasting future data storage, processing bandwidth, requirements is based on business growth, application usage, and other factors. When we're doing capacity planning, it helps to organize it helps organization allocate resource effectively, ensuring that sufficient capacity is met for current and for future demand while optimizing cost, right? And it also helps balance performance, cost, and scalability to avoid over provisioning and ensuring that the resources are utilized. So that's one of the reasons we do capacity planning. So when we look at like a scenario like a data center, right? Let's look at this. A data center need a reliable power supply to keep system running. This include backup power source like uninterrupted power supply and storage. A hospital store, an example, an hospital store patient's data is secured data center. If there is a power outage, backup generator keeps the system running, so no um, doctors can still access patients, so that doctors can still access patient data. So it's important. that when we are doing the capacity planning, that we plan it so that there is constant processing power, there are network speed, there are storage, just in case anything happen. We have to build a system to be able to handle whatever will happen. Okay, do you all get that with this? Okay, do you all get that? So power in a data center, right? Power in a data center. A data center need a reliable power supply, like we said. They must be able to function, and it's the same thing. When we talk about the data backup, involve making copies of important information and storing them in a safe location. There are different types of data backup. You have full backups, incremental and differential backup, right? A business may backup its file every night to an external hard drive and a cloud server, and it's if a ransomware attacker happen, the company can restore files from the backups. This should have been first, but it's okay. So the data powering, uninterrupted power supply. A UPS provider provides a backup powering source for critical equipment, um, making sure that there is a bridge of gap between the power outage and the activation of the generator. So we have to make sure that that's what we talk about, like powering data center, right? Ensuring that there is no disruption. But before I move any further, let me run quickly to our objective to see where we are. So right now we just did capacity planning, and we're looking at power data center, right? So power data center, right? And then we will do some multiple choice. So the capacity planning and power data center, we're going to do the multiple choices together. So let's run back down here. We'll look at RAID. We'll look at capacity planning and how important that is, right? So remember now, it's very important for capacity planning. And we look at power in data center. We say that a data center needs a reliable power supply, whatever data center, because places like Google, places like all of those, they have a data center, right? And those center have to make sure that there are constant power supply just in case anything goes wrong. Okay, so I will see you in the next session.